So how did 1.1 go? Hopefully not too terrible for you. I know that anytime you're dealing with a lot of new terminology, a lot of new words, that it can be difficult to kind of keep everything organized. So the more practice you can do, the better off you're going to be. So now 1.2, we take a little bit of a direction change here. We start talking about linear measure. Okay, so we start talking about, how do we measure not whole lines? Because remember, lines go on forever. Okay, so lines have a certain number of points and they go on forever. So those are going to be unmeasurable. Okay, but so we talk about kind of different pieces. Okay, so we talk about a part of a line, a piece of a line. We talk about a line segment. Okay, and a segment is nothing more than just part of a line. Okay, so when you consider that I've got a line, and we can go just keep simple, A, B, C. I cannot find the measure of line AB, line AC. But what I can do is figure out the measure of line segment AB or line segment AC. So here's the difference. When you name it, you're naming it by 2 points, but you have kind of endpoints. So if I have AB, I just have that. Notice how that is different than line AB, which would be represented by this. Okay, so this line AB has got 2 arrows on it, right? The segment has no arrow. So that's the difference. It's a subtle difference, I'll grant you. But that's kind of the big idea. So my example, if I have AC, that's a segment. BC, that's a segment. Okay, that's the difference. So I'm basically saying, hey, I don't want to deal with the whole line. I only want to deal with this certain part. So can you find the length of a line? No. Why? Lines are continuous. I feel like I spelled that incorrectly. Let me see something here. Nope, I feel like I was right the first time. So it's continuous. Okay, lines are continuous. Cannot find the length. Can you figure out the line of a line segment? Yes. Yes, absolutely. Yes. They have distinct endpoints that can be measured. So, when you look, most rulers are going to have inches side and a centimeter side. Inches is very American. It's considered a standard form of measure. And centimeters or millimeters or even kilometers, once you get to that length, that's considered the metric. Okay, and that's what the rest of the world uses. We came up with inches and feet as Americans, and it's kind of what we do. So if I look, letter A, so I have this line segment, starts here and ends here. So this is between 3 and 4. It's not very difficult to see that that's not on 3, it's not on 4, it's somewhere in between. But it's a little past what I would consider halfway. So I would consider something to the effect of 3.7 or maybe 3.75 centimeters for that length. Okay, so you count 1, 2, 3, then not quite 4, but maybe about 3/4 of the way there, about 3.7. So and this is not as ideal, it's not as finite as I would like, but it's worthwhile to at least be in the neighborhood. So this one, letter B, much more detailed. So you still have, so each big number is centimeters, and each little piece in here, those are millimeters. Okay, and that's one of the conversions. 10 millimeters is 1 centimeter. So when you look, 1, 2, 3, and then 1, 2, 3, 4, 5, 6, 7. Okay, so this would be about 3.7 centimeters, or 37 millimeters. Okay, normally you'd want centimeters. Okay, normally you want centimeters, but either one would technically be acceptable. So that's measuring in standard. So now this we're dealing with inches. So you're dealing with standard here. So all the big numbers are inches. And then in between here, they're not like the equivalent of millimeters. This would just be considered a half inch. Halfway in between, that would be 3/4. That would be 1/4. The way that inches breaks up is that they break it up by 16ths. Okay, so they break it up by 16ths. So 1/16, 2, 3, 4 out of 16 is 1/4. So this would be 8 out of 16, which is 1/2, and so on. So we have 1 inch, and then we go 1, 2, 3, 4, 5. So this would be 1 5/16. And many tools, if you've ever worked with any tools, if you've ever worked with any ratchets or anything, they have measurements in inches. They have a 5/16, wrench or a 5/16 ratchet set or anything like that. So now down here, number 3, this is just broken up into fourths. So this would be 1 inch. So this would be 1/4, 1/2, 3/4. So 1/4. So this is going to be 1 1/4 inches. That's all I would need to write there. Okay. Couple of conversion pieces that you should know. This got cut off, and I'm not sure why. So 1 yard is going to be 3 feet. 1 meter, okay, 1 meter ends up being 100 centimeters. But 1 foot is 12 inches. 1 centimeter is 10 millimeters. 1 mile ends up being 5,280 feet. And 1 kilometer is 1,000 meters. Okay, 1,000 meters there. So just a couple conversions. The more you can understand about conversions, the more your physics and your chemistry teachers will thank you. So just be aware of that, please. This is one of the ideas in geometry that it's rather painfully obvious, but we do need to mention it. The concept of betweenness of points. And here's all it says. If we say something is between something else, then it's going to be collinear. Okay? So if we say that, point S is between R and S. Okay, I'm point R and point S is what I'm talking about here. So if I say, not R, sorry, rather T. If I say that S is between R and T, okay, I'm really saying that S is collinear with R. And I'm also saying S is collinear with T. So again, if I just say, hey, S is between R and T, logically that makes it's not even worth. You would think that's not even worth mentioning. It's obvious that it's between. Well, in math, sometimes we have to be painstakingly obvious because you don't want something to say A, and we'll call that C, and B would be between A and C. That would be obvious. But now we have a question here. is point X between A and C? Is point Z between A and C? Well, the answer is no, because between A and C, you are talking about just this line. Okay, so X and Z are not between A and C. Okay, so just be aware of that, please. So between is just kind of another term that you need to be familiar with. Okay, so let's look. So find the length of XZ in the diagram below, given that XY is 4.5 centimeters and YZ is 3.2 centimeters. So they want the whole thing. Okay, so, and we're also, one thing I should have mentioned with between this. So Y is between X and Z. Okay, and one of the other ideas that they mentioned about this, and this is another thing that's like, okay, that's kind of stupid. Who would even think of this? Is that if I say it's in between, I would say that it's continuous. And what I mean when I say that is you have X, Y, and Z, that it's not, X to Y, and then a little space, and then Y to Z. Okay, it's not that case. Okay, there's no magical little space in there in between those. Okay, it's a continuous segment there. Okay, there's no magical space in between. That doesn't exist. Okay, so for here, this is simply a matter of adding 4.5 plus 3.2. So I'll just be 7.7 centimeters. And we're done. So now, they don't give us a picture, but they say, find X and ST. T is between S and U. Okay, so T is between S and U. We don't know where. Okay, it's arbitrary. It's not absolutely necessary. So we have S, we have U. T is somewhere in between, and that matters not very much. So they tell us ST is 7X. SU is 45. And TU is 5X minus 3. So these two together make the whole thing. So that would be 7X plus 5X minus 3 equals 45. So now it becomes an algebra problem. So this is just simplifying. That becomes 0. Little division. That becomes 1. X is going to equal 4. Now, you're not done. Many students would say, hey, I figured out X, I'm done. Well, that's algebra. Geometry, you also need to kind of see, does that literally answer the question? Well, we found X, but we also need to find how big ST is. Okay, so ST is, once again, right here. So ST is 7X, but we know what X is. X is 4. So that's going to be 28. I'll call that 28 units. So we were not done. We had to find ST. So now let's look at another one. So find the value of A between and XY. Y is between X and Z. Okay, again, it's nobody's saying it's exactly in the middle. They're just saying, hey, here's X, here's Z. Y is somewhere in between. Okay, Y is somewhere in between. And Y could be anywhere in between there. That's fine. So they say that, let's see, 3A, XZ, this whole thing, is going to be 5A minus 4, and YZ is going to be 14. So once again, these two things together add up to the total. So 3a plus 14 equals 5a minus 4. So now, two-step algebra problem. Well, more than two steps, but I'll combine them. So that becomes 0. That becomes 18. That becomes 2a. That becomes 0. A little division. So a is going to equal 9. Okay. So now we're not done, because now we need to find xy. Well, xy is going to be 3a. But I know what a is, so I just do a little multiplication, and that's going to be my answer, 27 units. Okay? So it's getting used to the idea that the two parts together make up the whole thing. So, in geometry, we have this idea of congruence. Okay, congruence is like a geometric version of equals. Okay, that's about the easiest thing I can compare it to. Congruent literally means has the same measure. Okay, if two things are congruent, they have the same measure. So if I got out a ruler and measured MN and QP and figured out those were both 2.1 centimeters, I can say segment MN is congruent to segment QP. All right, because they have the same measure. Okay, that's why. That's the term. So congruence you will see a lot. So get used to that concept. Okay, and it's not exact, it's a subtle difference. It is not the same as equals. Okay, this congruent symbol is not the same thing as an equal sign. Okay, it means those two things have the same measure. It's a subtle difference, but it's still important. Okay, so kind of think about that idea for a little bit while you're going through this. Okay? All right, well, now you do the 1.2 assignment. And then go get 100% in quizzes. And make sure that you come talk to me with any questions. Okay.